This microchip can extend your Wi-Fi over 10 miles, and we're just getting started. Tiny, cheap, and unregulated, these devices tap into a new flavor of Wi-Fi, long range, low power, and built for IP mesh networking. Each one acts as a node in a decentralized swarm of IP mesh radios, routing peer-to-peer data in real time across rooftops, in backpacks, and even drones. And the most exciting part, it's barely been touched. This is wireless reimagined. Tech like this flies in the face of everything big tech is pushing right now. I'm talking toothbrushes with subscriptions, dishwashers that need Wi-Fi permission just to run a cycle. It's a regressive trend that might look good on big tech's income statements, but it locks us into endless fees. That might be the default path, but we're building in parallel because this you can actually own. You can open it, repair it, reuse it. You can teach your kids how to use it and how to make it better. It's open and it's yours, which is something this channel really supports. Today, Wi-Fi is something we fix to our residence or place of business to give local devices a connection. But tomorrow, Wi-Fi could be something that roams with us into the mountains, on kayaks, out to the most remote places we travel. To prove exactly how Wi-Fi is evolving, I'm gonna build something that's never really existed for the consumer before. A mobile peer-to-peer Wi-Fi mesh with no towers, no satellites, and no centralized control. Just small IP-based mesh radios, moving and routing packets in real time, and doing it with all off-the-shelf parts that anyone can buy. Technically, it's called a mainnet, or a mobile ad hoc network. And with this setup, every device is a node, and you create a decentralized swarm that keeps itself alive even if nodes drop out. The military has been using this tech for years. Devices like the MPU-5 is battle tested. It's literally built for war zones, but it's also priced like it. You're looking at 15 to 20K per unit, once you factor in software, antennas, and licensing. But this, it's a smaller architecture, just under $50. Open source, civilian grade, but suddenly possible. For years, systems like these have been locked behind defense contracts and big budgets, but now pieces of that puzzle are bleeding into civilian hands. And we can piece it together, serving as another nail in the coffin for a truly parallel wireless network. But theory is one thing and reality is always another. So I'm going to be testing it here in Brickell. I'm also going to go more remote to some of the islands surrounding the area to test exactly the limits of this tech. But the stakes here aren't just academic, and I always consider the implications of tech like this on how it might affect my life. And as a quick anecdote, my best friend and I like to hike the White Mountains in New Hampshire. Specifically, we like winter hiking. It's absolutely stunning, it's dead quiet with the snow, but it can also be brutal. There's no phone signal, and -20 wind chill definitely ups the ante. Up there, getting lost or injured, even for a few hours, can be fatal. And not because people are reckless, but because mistakes happen fast, and with help out of reach, it's really easy to underestimate the elements. That's why tech like this matters. I'm not saying it's a fix, but if a tiny off-grid mesh node could shift the odds even a little, that's worth exploring. But let's be honest, maybe there's a reason people don't use this stuff. I mean, HALow is barely supported, and ATAC's meant for military radios. My worst fear is that tools like this give people a false sense of security and ultimately are unable to deliver. But I guess the only way to truly know is to give it a try. One of the things I love about this project is it's pure open source. So that means you buy it once and you own it forever. There's no licenses, no cloud logins, no gatekeepers. If you want to mod it, you can flash your own firmware and just have at it. This thing is built for control. And then I'm going to be using this as my HALow roaming client, and all it is a Xiao from Seed Studio, so an MCU with a Wi-Fi HALow adapter and an FPV camera. I will need power for this, obviously, as well as the antenna. I will need power for this. You could use a power bank or something like that. I've been messing around with these 18650 batteries and been having a lot of fun with them. And this one has a USB connector here. So actually, I can actually use USB-C to power the MCU, which is what I'm gonna do for this video here. But basically, this board here has enough code to generate the video stream from the FPV and expose it over an IP address. And so really, once I have the video stream going with this can go, like a mile away from the router, which really opens up a whole new world of possibilities because it uses traditional IP networking and has the throughput to be able to support even like lightweight video streams and things like that, which is something that Meshtastic and LoRa just can't quite do yet. So in a future video, I'll build a proper mainnet and we'll actually show HaLow like on the move. But I just wanted to demonstrate here that like it's even like theoretically possible, and I do get it working in my apartment here. And basically like I live stream a video over HaLow to ATAC. Which in and of itself I think is pretty impressive. And again, guys, just to reiterate the setup here, right? Because there's lots of moving pieces and I don't want you guys to get lost, right? So basically what's happening is the router that I use is the Wi-Fi Express. That's my home router. This device, the ATAC device, connects to the Wi-Fi Express. And it uses 2.4 and 5 gigahertz bands to connect to that. And that's all well and good, right? So I have my home network and this is able to connect to it over Wi-Fi. Fine. But where does HaLow come into the mix? So with HaLow, depending on the setup that you have, every device that needs to leverage HaLow needs to have HaLow, essentially. It needs to have either a HaLow client or a HaLow access point, essentially. So what I do is I make my Wi-Fi network, the Wi-Fi Express network, compatible with HaLow with this setup here. This is a Raspberry Pi with a HaLow chip and a HaLow antenna, and all I do is plug it into Wi-Fi Express with Ethernet. And what happens is it basically extends my Wi-Fi Express frequency, but it keeps everything with the same IP networking in place. So basically, if another device broadcasts itself on the HaLow frequency, then anything on that unified network can access it. So basically this setup right here, just Wi-Fi HaLows it enables Wi-Fi HaLow on my Wi-Fi Express router. Now, it's not actually going to do anything with that HaLow until there are actual clients broadcasting themselves on HaLow. Enter the Xiao, right? This is going to be one of the clients. And so where you can introduce distance with HaLow is between HaLow clients, right? So what I could do in theory is I could take my confined HaLow roaming client here, and because this is set up to connect to this, you do a little SSID handshake. Basically, you just put the SSID username and password into here that you set over here. And again, once these can connect to each other, anything this exposes in terms of an IP address is available to anything, not just the HaLow, it's available to anything on the Wi-Fi Express network, aka ATAC. So what's going to happen is I'm going to pop open ATAC on this, and it's going to be able to open a video stream directly being broadcast from this device, even if this is like a mile away, 2 miles away, or whatever, because they're just all being daisy chained. And it really works. I was able to set up a video stream using the HTTP protocol, because that's what this is set up to use. This spins up a webcam on an HTTP, very lightweight, and I can share that code with you. But then this streams it directly. And what's really happening is this is making its HTTP web camera server available to the entire network, because it can send it to the access point, And then the access point uses Ethernet to plug that into our broader Unified Express network, which this leverages. So again, I'm going to make this more simple and come up with an actual mobile ad hoc network setup using Wi-Fi HaLow. But here in my apartment, and for the sake of getting this video out the door, I just wanted to demonstrate that it is in fact possible. And the fact that we're able to do a live video feed with a HaLow client that isn't even a real SBC. It's an MCU. It's working with like a 1/4 megabyte. It's working with like no RAM, no storage, and it still works. To me, it just proves how good this tech is getting. Like the Xiao is literally like a $6 board, and it can support stuff that like those $1,000 Ubiquiti routers can't really dream of. So, I mean, we're getting to the place where some of this stuff that has been reserved for like military setups and Department of Defense and all that stuff is more accessible to the layperson, which is something that really excites me. So definitely check out the guides in the description below, because I'll walk you through exactly how to set all this stuff up, provide links to gear, and some back channels if you guys have questions. All right, let's get this thing online. Okay, so what we're trying to do here is set up a mobile ad hoc network. So I have ATAC going on this device here. I have a 2.4 to 5 gigahertz local wireless router here. This is going to be our central WAN network, so our central wireless network. However, this does not have any sort of long-range radio capabilities, right? This is just 2.45 gigahertz. So that's where we're going to actually connect the Raspberry Pi with the HaLow hat, which is going to bring Wi-Fi HaLow to the party. And then we do have a client so we can test like how far we can go away with another Wi-Fi HaLow chip. And we're going to basically try to stream video in a very remote area out here and see how far we can go. Now, this is not a true mainnet due to one point, which is that it doesn't have mesh networking. And we're going to do that in a future video. We're going to put the main open source software is called Batman. We'll throw that on the Raspberry Pi, and then it'll have true mesh networking with the 802.11s, I think it is, or but anyways, it'll be able to do mesh networking with the Wi-Fi HaLow protocol, which is kind of the grand vision of this whole thing, and is kind of the true mainnet. But this is going to be just kind of a base level example. All right, so we have the Unified Express, our base wireless network. We have power. This guy has to have, 3 amps, I believe, in order to power this thing, but it looks like it's working. And then we have our HaLow access gateway, which is connected to this. So everything HaLow picks up will show up on our Wi-Fi network. The HaLow antenna, luckily this has a magnet, so that just sticks there. But we need to power this guy, so I'm hoping I can get that done with this. I got it to work back in my office. It doesn't fully support the level of power needed here, but I'm hoping for the best. So I'm gonna go ahead and plug this guy in. We do see some lights come on, so that looks promising. And then I just have the T1000E to bring some Meshtastic to the mix. And I'm gonna see what that looks like on my phone here. So I have, yeah, this is like a fake Samsung Galaxy. I got it off Temu, but it runs Android. Should get the job done. Let's see if we can't get this going here. The thing is, I need to put this on that Wi-Fi network. Okay, so I just joined the network here. So this guy is on this local network. So I go over to ATAC. Okay, so we can see the map. That's all good. But I should be able to see my other phone. So let me turn that on real quick. Okay, so now we see my other device here, right? So this other device is literally the iPhone that I'm shooting this with. I kind of forgot my other device, unfortunately, but it still makes the point, right? This is one ATAC device. It's on our mobile Wi-Fi network here, but this iPhone is also on it, so I should be able to send messages. I'm gonna go, hello. Okay, so this sends a message, and then I'm gonna look on my iPhone to see if I received that message. and I just took a screenshot. I did receive this message. So now, again, any ATAC devices that are on this network can now communicate. They can message. They can also do other things, like they could send video streams, they could share maps, they can superimpose drone feeds onto the maps. So there's quite a bit that they could do. But they just have to be on the same network. But the question is, we're out here, right? This is our network. So if you were on a hike, or you were on a kayaking trip, or doing some sort of search and rescue, you need long distance, right? And that's where Meshtastic really shines, right? So you could give everyone one of these, and now you have long distance radio, and you're adding that to the party. But it's not true IP networking. It's kind of running in parallel to the actual ATAC system. So what I would do is actually introduce Wi-Fi HaLow, which brings true IP networking, and then true mesh networking and long distance. So if all your nodes in your in the ATAC network had Wi-Fi HaLow, I mean, they can do everything they can do over IP. I mean, you could go to Instagram, provided one of them has like a downlink from like Starlink or something like that, but they could send video over long distance. They could do all that stuff. And so actually that's what we're going to do for our little example here. I have this guy. Now this is super lightweight, but this is a HaLow chip with an FPV camera on a Xiao with a antenna, and a long distance antenna. So and I'm going to try to get that going here in ATAC itself. So you go over to settings, and then you go over to video, and then I've already set up the configuration here. I just need to theoretically power this guy on. Now I've been having a lot of fun with these batteries. This is an 18650, which is a fairly common battery, but it has a USB side port, which is actually quite practical. So I'm gonna go ahead and plug this guy in. Okay, so what I'm basically doing is I'm just gonna power this guy on. It has all the firmware. So right when it powers on, it should start an HTTP stream camera server, and I should be able to pick that up on any of the devices on my network, frankly, but also right in ATAC. So that's kind of my goal here. Okay, hopefully you can see that, but we do in fact have our Wi-Fi HaLow client going, and we are using our mobile ad hoc network. We're out here in the middle of pretty much nowhere, and it's streaming live video directly to ATAC. So now the question is, like, how far away from, you know, this whole setup can we actually go and continue to get a signal? So that's what we're gonna test. All right, so we have our super janky little HaLow camera here, and you can see that it is sending a stream to ATAC, but our network, this is what's interesting, our network is out here. So my question is, how far away can we bring this guy and this can continue to get video? So that's what we're gonna test. Okay, so we can see the car right there, right? So that's node number 1. This right here is node number 2. We're streaming video, which is pretty high, a high bit rate activity, and we're just trying to see how far it can go using Wi-Fi HaLow. In the future, when I do this, I'm gonna have two true mainnet setups, and everything should just be using Wi-Fi HaLow under the hood for like all the networking, IP networking stuff, and it should just bring long range to the party. And right now we're just like doing a direct video stream, but when I do the future video, we're gonna have 2 true mainnets, IP mesh networking, Wi-Fi HaLow, 802.11s, Batman, etc. So that'll be more plug and play than this. Okay, so we have this guy going right here, and that second node is all the way over there. That first test actually worked, and I went all the way to the other side of that big football field. So I need to actually push it further because that worked. But what I'm thinking now is maybe I'll keep the camera in one place and then drive the car beyond to see, maybe that'll work. I just don't want everything falling off here, so let me figure this out. All right, I think we're gonna have to settle for that. So let's make sure that the stream is still going. Okay, so I think our stream is still good, as far as I can tell. Okay, so I'm running ATAC in my car. This is my main network. It's a Wi-Fi Express router. That's a Wi-Fi HaLow gateway on a Raspberry Pi. And that camera feed is coming from that tree right there. That's a Xiao. Remind me not to open the sunroof. And I go like this, I can wave and you'll see me. That is me out there. And let's go ahead and see if we can keep this stream going. All right, and we should see the car cross. Oh God, that's bumpy. We should see the car cross in a second. Let's see. Moment of truth. There I am. Still getting a live feed. That's over Wi-Fi HaLow. So let's push it a little bit further. It will stop streaming when it stops working. So let's see how far we can get this. Still getting the feed, and we're going directly away this time. Still getting the feed. All right, I'm gonna pull in so we can do a little comparison here. So you actually should be able to see the car at some point. Let's see here. Yeah, you can see that car. So we're still getting a feed. So let's push it further. If you want to see how far we're getting a feed from, it's going to be all the way basically towards that green fence down there. So it's pretty far. All right, and now it's giving us a little bit of trouble. So I think we might have hit our limit here. Okay, so we set up our poor man's mainnet and we got it working in a very remote area along the water here in Miami. And we did set up a Wi-Fi HaLow FPV camera. So fairly high bitrate use case, streaming video. But we were able to get that to work. I would put it at the limit of 1,500 feet. So, you know, more impressive than off-the-shelf Wi-Fi routers, but not quite cut it for like search and rescue teams and things like that. Now, that being said, there's quite a lot that we can tweak to make this more appropriate for those sort of search and rescue or even more remote off-grid activities. For instance, Wi-Fi HaLow supports different channel widths, and the lower you go, the more distance you get, although the less throughput. So there's quite a few things we could do. Like for instance, we don't need to be streaming video necessarily, or we could stream lower bitrate video, or we could try those lower channel widths like 2, 3, 4, even 1 megahertz. And technically that should go further. Also, for this range, the sub-gigahertz range, which is things like LoRa and HaLow and stuff like that, we're talking around 915 megahertz, the most that you can do in terms of power, and power is one of the big drivers of range, right? The power of the antenna and that sort of thing. The most you can do is 1 watt. 1 watt of power, which is the equivalent of 30 dBm. Now, interestingly, this hat that I have, the Seed Studio hat, with the OpenWRT image that was generated by Seed Studio was running at 21 dBm. Now, I spoke with someone who reached out to me who was able to create another image for the Raspberry Pi using the same HaLow chip and actually using the mesh networking as well. And he was able to modify the software to bring it up to 27 dBm. So I'm going to use his firmware in a future video to see if we can get more distance. But I'm also going to mess with those lower channel widths to see if we can get HaLow to go further. But I'm also just going to do a proper mainnet. This isn't really a proper mainnet. There's no mesh networking. We did a very kind of rudimentary proof of concept in terms of streaming the actual video. And what I want to do is have a mainnet that can support 2.4, 5 gigahertz, HaLow, and kind of, I guess, LoRa through the back door. Using the Meshtastic plugin, but really I want to rely on HaLow for that long distance and tweak it so that maybe it doesn't have to do video, but it can do telemetry, and that telemetry data is far easier to transmit, and therefore we could probably send it a lot further. So that video is going to be coming up, but I did want to just kind of give you an introduction to what these sort of mobile ad hoc networks can actually do, and it's quite impressive that I kind of rigged this whole thing to run on the car, and then the car was moving around and it was able to get a connection. And again, this is all like inexpensive hardware. Raspberry Pi is $35. The antenna is $5. The HaLow chip is $15. The hat is, I think, another $15. This is just an Android device that I got off of, funny enough, Temu. It's a Xiaomi device. I'm running the APK that I got from tac.gov, so no middlemen, no Google Play Store needed. The case is, I bought this case off Amazon, and then I spray painted it with a flat dark earth spray paint, and I don't know, I actually think it looks quite nice. So to me, one of the beautiful things about this is the whole ecosystem is open. You can tamper with it. You actually own it. There's no middlemen. There's no tracking in terms of big tech wanting to send its own telemetry data to know how you're using it. They can't, cut you off or gatekeep and things like that. And I love that. I love tech that you can own, that's inexpensive, that's cheap, that works. ATAC comes from the military, so like they actually know what they're doing. I see a potential trend here in terms of this software becoming more ubiquitous as an alternative to things like Google Maps, Apple Maps, and things like that. And similarly, how I said that we can change the dBm of this build for the Seed Studio HaLow hat, I actually think we could probably modify the same component in the actual MCU so that this is a little bit more power and therefore getting more range. You know, if you had some people going off-roading like in Jeeps or something like that, and say one of them had like a Starlink mounted to their vehicle, right? So that's like a downlink of, an actual internet connection link. But then use something like this to make that link available to all the nodes like in the vicinity. And if you're using HaLow, you can get something like 1,500 feet, or I'm thinking we can probably get even more as we tweak things. I mean, that's pretty compelling. You could be out in the middle of nowhere and you could get onto like Instagram or something like that, which just feels kind of surreal. So lots of potential here, and I'm going to be building out a lot of this stuff further with future builds, future content. Also, if you guys want to save some time and build some of this stuff yourself, I have a couple guides on our website. I'll put that in the description below. Again, this is all stuff you can figure out on your own, going through Reddit threads and stuff like that. But if you want kind of proven step-by-step tutorial and to save a little bit of time, then you can go ahead and pick up one of those field manuals in the description below. And I've been super impressed with some of these new form factors in terms of batteries. I mean, this right here is a 3200 milliamperes. So this is about the same amount of power that like a phone would have. So quite a bit of power. And it just works pretty easily with things like MCUs and stuff like that. I am going to be doing some more experimenting with daisy chaining some of these batteries and things like that. But There's also a bit of a renaissance in the battery space with LiPo, PO4, these 18650s, and all the different types of batteries currently available. There's a lot of cool stuff that is being done on that front as well. And even with things like solar and stuff like that. So I don't know, I think one of the interesting things to me about how technology evolves is it evolves in all dimensions. So it's not just the software, it's the hardware, it's the lenses, it's the glass, it's the cases, it's 3D printing, it's the batteries, it's every single component gets better. And when you put all those marginal improvements together, the technology just becomes very, very compelling. And it's really cool to see what you can do in the open source world with a little bit of elbow grease, and how we're really not at the mercy of big tech anymore in terms of like Apple and stuff like that. You can really run a lot of this stuff using open source alternatives, which is definitely not mainstream right now. Everything's subscription and cloud and this and that, but I do see a potential future. Particularly, we're seeing things like the home lab trend, where people are, running appliances locally, having their own local AI models. There's definitely a there in terms of deploying things locally on increasingly inexpensive hardware. Your move, Comcast. And just like that, you don't need a carrier because you are the carrier. For more killer tech videos, check out this next video.